everyone. My name is Namrata Verma, Assistant Professor in the Electronics and Telecommunication Department at Sri Santosh Rungta Group of Institutions, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. Today, we are going to discuss about the description of amplitude modulation and then the generation of the amplitude modulated signal. We are going to discuss today's topic with the following points. We are going to start with the definition of modulation, then need of modulation, then introduction of amplitude modulation, representation of amplitude modulation, advantages, disadvantages and application of amplitude modulation. Then we will discuss the methods for generating amplitude modulating signal. Basically, there are two methods for generating amplitude modulated signal. The first one is square law modulator and the second is the switching modulator. Now, first we will see what is modulation. Modulation is a process in which some characteristics of a carrier signal, that characteristics may be either amplitude, frequency or phase of carrier signal, is varied according to the instantaneous value of the message signal or information signal, which is called as modulating signal. And the resultant signal that we will get after this process is called as modulated signal, and the process is called as modulation. Depending upon the different characteristics of carrier signal, which characteristics is varied according to the carrier signal, there are different type of modulation. As characteristics for continuous time type of carrier signal is amplitude, phase and frequency. Therefore, on the basis of that, there are three types of modulation, which are amplitude modulation, frequency modulation and phase modulation. Next, we will see what is the need of modulation. Information and signal are sent from one part of the word to another within minutes. The modulation process plays a major role in the fast transmission of signal. Therefore, importance of modulation in the communication system are: first one is reduction in the height of antenna, second, avoid mixing of signal, third, increases the range of communication, fourth, multiplexing is possible, and last one is improve the quality of reception. Now, we will see the detailed description of each point. First, reduction in the height of antenna. For transmission of radio signal, the antenna height must be multiple of lambda by 4, where lambda is wavelength and which is given by lambda is equal to c by f, where c is the velocity of light, which is equal to 3 into 10 to the power 8 meter per second, and f is the frequency of the signal which is to be transmitted. The minimum antenna height required to transmit a message signal of frequency 10 kHz. Then the height of the antenna is calculated as follows by the formula: height of the antenna should be lambda by 4, which is equal to c upon 4 f, and now substituting the value of c and f, then we will get 3 into 10 to the power 8 divided by 4 into 10 to the power 3, which is equal to 7500 meters or 7.5 kilometer. The antenna of this height is practically impossible to install. Now, let us consider this message signal is modulated and the frequency becomes 1 megahertz. Then, the minimum antenna height is given by lambda by 4, that is equals to c upon 4f, and now the frequency becomes 1 megahertz, then the minimum height of the antenna becomes 75 meters. This is practically possible to install the height of the antenna of 75 meters. Now, second one is avoid mixing of signals. If the message signal are transmitted without using the modulation by more than one transmitter, then all the signal will be in the same frequency range, that is from 0 to 20 kilohertz. Therefore, all the signals gets mixed together and a receiver cannot separate them from each other. Hence, if each message signal is modulated with a different carrier, then they will occupy different slots in the frequency domain, and therefore modulation avoids mixing of signal. Now, third one is increase the range of communication. The frequency of baseband signal is low, and the low frequency signal cannot travel along long distance when they are transmitted, and they get heavily attenuated. The attenuation reduced with increase in frequency of the transmitted signal, and they travel longer distance. The modulation process increases the frequency of the signal to be transmitted, and therefore it increases the range of communication. Now, fourth one is multiplexing. By modulation, multiplexing is possible. Multiplexing is a process in which two or more signals can be transmitted over the same communication channel simultaneously. This is possible only with the modulation. The multiplexing allows the same channel to be used by many signals. Hence, many TV channels can use the same frequency range without getting mixed with each other, or different frequency signal can be transmitted at the same time. Fifth one is improves quality of reception. With frequency modulation and the digital communication techniques such as PCM, the effect of noise is reduced to a great extent. This improves the quality of reception. Now, we will see the amplitude modulation in detail. In amplitude modulation, the amplitude of carrier signal is varied according to the instantaneous value of the information signal. In frequency domain, the frequency of carrier signal is varied according to the instantaneous value of the information signal, and similarly in case of phase modulation, the phase of the carrier signal is varied according to the instantaneous value of the information signal. Now, we are going to discuss the amplitude modulation in detail. Amplitude modulation, which is also called as AM, is a technique which is used in electronic communication, most commonly for transmitting information from transmitter to receiver by radio waves. The definition of modulation involves the three types of signals, which are carrier signal, message signal, and modulated signal. The carrier signal is a high frequency signal with constant amplitude, phase, and frequency electromagnetic wave that carries no useful information except its frequency and amplitude. Now, next is the modulating signal. This is the actual information that needs to be transmitted is called a modulating signal or message signal, which is basically a low frequency signal that needs a high frequency signal for its transmission. It is also called as information signal or modulating signal. It could be any form of data like audio form, a radio broadcast, or video data. The signal that we will get after the modulation process is called as the modulated signal. In amplitude modulation, the amplitude or strength of the carrier wave is varied in proportion to that of the message signal, while frequency and phase of the carrier signal is constant. This modulation technique conveys information over the carrier wave by varying its amplitude. The amplitude of carrier wave is changed according to the amplitude of message signal. When the amplitude of message signal increases, the amplitude of modulated carrier wave also increases. Conversely, when the amplitude of message signal decreases, the amplitude of modulated carrier wave also decreases. The sinusoidal modulating signal or message signal represented by XMT with frequency omega m and amplitude am, which is given by xmt is equal to am cos omega mt. Give it equation number 1, where xmt represents the modulating signal, am represents the maximum amplitude of the message signal, and omega m represents the angular frequency of message signal in radians, which is equal to 2 pi fm, where fm is the frequency in hertz. A high frequency carrier wave is represented by xct, or having frequency omega c and amplitude ac, which is given by xct is equal to ac cos omega ct, giving it equation number 2, where xct represents the carrier signal, ac represents the maximum amplitude of the carrier signal, and omega c represents the angular frequency in radians, which is equal to 2 pi fct, where fc is the frequency in hertz, and where omega c is very greater than omega m. The amplitude of a amplitude modulated wave is given by A, which is equal to AC plus xmt. From the equation 1, we can substitute the value of xmt, then the above equation becomes A is equal to AC plus AM cos omega mt, giving it equation number 3. The expression of the amplitude modulated wave becomes St is equal to A cos of omega ct, giving it equation number 4. Then from equation 3, substitute the value of the magnitude A in this equation number 4, then equation 4 becomes St is equal to AC plus AM cos omega mt whole is multiplied by cos omega ct. By opening this bracket, the above equation becomes St is equal to AC cos omega ct plus AM cos omega mt into cos omega ct, give it equation number 5. Now, we know that by the trigonometric formula of cos A into cos B, the above equation will be St is equal to AC cos omega ct plus AM by 2 cos omega c minus omega mt plus AM by 2 cos omega c plus omega mt, which can be also written as in the form of AC. Then the above equation will be St is equal to AC cos omega ct plus AC by 2 whole is multiplied by AM upon AC cos omega c minus omega mt plus AM upon AC cos omega c plus omega mt. In terms of modulation index, the above equation can be written as St is equal to AC cos omega ct plus AC by 2 mi cos omega c minus omega mt plus mi cos omega c plus omega mt, giving it equation number 6, in which mi represents the modulation index that we will cover in later. From this equation, we can observe that we have one carrier frequency component, one component having frequency omega c minus omega m, which is called as lower sideband, and one more component having frequency omega c plus omega m, which is called as upper sideband. Now, this figure represents the amplitude modulated waveform, in which amplitude is varying according to the information signal. The modulation index is denoted by mi, and which is defined as the ratio of the maximum amplitude of message signal to the amplitude of carrier signal, and it is represented by mi or ma or mu, and it is expressed as mi is equal to am divided by ac, where am represents the maximum amplitude of message signal and ac represents the maximum amplitude of carrier signal. The modulation index indicates how deeply the carrier is modulated by the information signal. Depending upon the value of modulation index, we can categorize the modulation index into 3 categories. When the modulation index is equal to 0, then there is no modulation and the output signal is just as the carrier wave. Now, the first category is when the modulation index is less than 1. This is the case of undermodulation. The carrier amplitude varies within its original amplitude range, which gives to a clear and undistorted signal and represented by this figure. When the modulation index is equal to 1, then this represents the full modulation or 100% modulation, and the carrier amplitude can be completely nullified at the minimum point of the message waveform, achieving the maximum amplitude swing without distortion. And next is modulation index is greater than 1. This situation is called overmodulation. In this case, the amplitude variation attempt to exceed the unmodulated carrier amplitude, which leads to distortion and the creation of additional frequency component that can interface with adjacent communication channel. This figure represents the waveform of overmodulated waveform. In terms of modulation index, the expression of AM will be given by equation number 6. Then equation 6 will be S of t, that is equal to AC cos omega ct plus AC by 2 whole is multiplied by AM upon AC cos omega c minus omega mt plus AM upon AC cos omega c plus omega mt, or it can be also written as ST is equal to AC cos 2 pi fct plus AC into mi upon 2 cos 2 pi fc minus fmt plus cos 2 pi fc plus fmt. Based on the above equation, we can all observe that the AM wave have one full carrier and two sideband with frequency fc minus fm and fc plus fm. This AM is called double sideband full carrier. Now, the advantages of the amplitude modulation. The amplitude modulation is inexpensive. The second advantage is the amplitude modulated signal are reflected by the earth from the ionosphere layer, allowing them to travel further and cover a large region. Third advantage is the required carrier frequency is minimum. Next one is it requires the use of basic transmitter and receiver, and last one is as a result audio signal transmission and reception are simplified. Now, next is disadvantages. The amplitude modulated communication are extremely variable to the background noise. It is difficult for receiver of these signals to differentiate between signal and noise, and as a result the audio signal quality is low. If the amplitude modulated signal is weak, a complex configuration is required for the receiver designing. In terms of bandwidth utilization, amplitude modulation is less efficient. The modulated signal's bandwidth is twice the frequency of signal wave, and the amplitude modulation is similarly inefficient in terms of power consumption. That means it consumes more power and only the sideband power is used. Now, next we will see the application of amplitude modulation. The first application is broadcasting transmission using AM are made using short, medium and long waveband. Amplitude modulation radio receiver are consequently simpler and more affordable to produce since AM is simple to demodulate. Next application is many airborne applications such as ground to air radio communication or two-way radio connections for ground staff worker utilize AM in VHF broadcast. Third application is single sideband amplitude modulation is used for point-to-point or high frequency radio communication, which makes better use of the transmitted power and has a smaller bandwidth. Now, next application is television broadcasting. The video signal is transmitted by amplitude modulation, while the accompanying audio is carried by frequency modulation. Although digital broadcasting has largely supplanted analog system, and AM was fundamental in the early development of television. Now, next application is disaster communication. Due to its long range capabilities, especially in low frequency band, AM radio wave can be particularly useful in disaster situation where modern communication infrastructure is damaged or overloaded. It allows effective decimation of information over wide areas. Now, next topic is generation of AM wave. The circuit which generates the AM wave is called as amplitude modulator or AM modulator. Basically, there are two methods for generating AM signal. First one is square law modulator and second one is switching modulator. Both of this circuit use nonlinear elements such as diode for the generation of AM signal. First, we will discuss the square law modulator. This figure represents the circuit diagram for the square law modulator. In this circuit, we have two input signal. One is message signal or modulating signal, which is represented by x of t, and other is carrier signal, which is represented by AC cos omega c t, where omega c is angular frequency and which is equal to 2 pi fc, where fc represents the linear carrier frequency in hertz. Then the combination of both of these two signal, that is your carrier signal as well as the message signal, or we could say modulating signal, are applied to the non-linear device, which is nothing but your diode circuitry or transistor circuit or any device which have non-linear characteristics. Then this combined signal are passed through the LC tuned circuit, which is nothing but a band pass filter for proper filter. This is the description of the circuit which was discussed in the earlier slide. Let the modulating signal be MT and the carrier signal is denoted by AC cos 2 pi FCT respectively. These signals are applied as input to the nonlinear device, which could be your transistor or diode. For simplicity, we will consider here that it is diode and operating in nonlinear region. Mathematically, we can write that the input to the device is V1t, which is nothing but the summation of message signal and the carrier signal. This is passing through the diode and which is our nonlinear device. We can write input to the nonlinear device is V1t, which is equal to MT plus AC into cos 2 pi FCT. Then the diode resistor equation is given by V2t, which is equal to A1 into V1t plus A2 into V1 square t, where A1 and A2 are constant, where V1t is equal to MT plus AC cos of omega ct. Now substitute the value of V1t in the above equation, then V2t becomes, V2t is equal to A1, which is multiplied by MT plus AC cos of omega ct plus A2, which is multiplied by MT plus AC cos of omega ct whole square. Then the above equation becomes A1 into AC cos omega ct whole multiplied by 1 plus 2 A2 upon A1 into MT plus A1 MT plus A2 M square T plus A2 AC square cos square omega ct. Now this signal is passed through the band pass filter, and the first term is the desired AM signal, which is given by A1 into AC into cos omega ct, which is whole multiplied by 1 plus 2 A2 upon A1 MT with sensitivity mu is equal to 2 A2 upon A1. The remaining unwanted terms are removed by the appropriate band pass filter. Now, the second method for generating the amplitude modulated signal is switching modulator. The switching modulator is similar to the square law modulator, except the diode has to operate as an ideal switch in the switching modulator. This diagram represents the circuit diagram for the switching modulator. In this circuit, we have two input signal. One is message signal or modulating signal, which is represented by MT, and other is carrier signal, which is denoted by AC cos of omega c t, where omega c is angular frequency, which is equal to 2 pi fc, where fc represents the linear carrier frequency in hertz. Then the combination of both these two signals, that is carrier signal and the message signal, are applied to the diode circuit, which have nonlinear characteristics. Then this combined signal are passed through the band pass filter for proper filtering. The input to the diode is the addition of the message signal and the carrier signal, which is given by V1t is equal to MT plus AC cos of omega ct, where the magnitude of MT is very less than AC. The V2t, which is the output of the diode circuit, is given by V2t will be equal to V1t when the Ct is greater than 0, and for Ct is less than 0, V2t is equal to 0. For the positive value of carrier signal, V1t is multiplied by the function gpt, and therefore the output of the diode circuitry will be V2t is equal to MT plus AC cos of omega ct whole is multiplied by GPT, where GPT is given by 1 by 2 plus 2 upon pi whole multiplied by cos omega ct minus 1 by 3 cos omega ct plus so on. Now, this function is multiplied by MT AC cos of omega ct, then the output will be MT by 2 plus AC by 2 cos of omega ct plus 2 upon pi MT cos omega ct and so on. Now, this signal is passed through the band pass signal, which will pass the term having frequency omega c plus omega m and omega c minus omega m. Therefore, it will pass only the up to second term having the frequency omega c, and the third term, which is the product of MT and cos of omega ct, which gives the frequency term omega c plus omega m and omega c minus omega m, and reject the remaining term. Therefore, the output will be AC upon 2 cos of omega ct plus 2 upon pi MT cos omega ct, where constant AC upon 2 is equal to K1 and constant 2 upon pi is equal to K2. Then the output is nothing but the desired double sideband signal. Thank you.